Hello all. In this video we're going to learn about a couple new tools, in particular being split and merge, which are functions in OpenCV that let us pull apart the channels of an image and rebuild an image from its individual channels. And we'll also take a look at a concept called regions of interest. This is a term that's used in computer vision to describe a section of an image that is the section we want to focus on, and we'll take a look at using slicing as we've done before, but a little more targeted way to pull out sections of the image. And we'll try to take a look at some of the ramifications of doing that. It's a very useful tool for us, as you will see. All right, so here's the section in my notes. It's talking about the split and merge functions. These are paired together. And now, you have to be careful. We just learned about a split method for strings that takes a string and splits it apart based on certain characters that occur in the string. This is different. This is OpenCV split. And what it does is always takes in a color image, something that has multiple channels, and it breaks it apart and returns a tuple where the values in the tuple are the separate channels. It does not necessarily copy the data in a new way, but I think it copies the data so that you're working with a new set. The merge function, you can give it a tuple containing 3 channels, and it will put those together as red, green, and blue values. So it basically lets you explode out the channels or put them back together, the pair of them. So I have a sample program here in my notes that is also looking at making negatives of an image. So negatives come from the original print photography, where what would actually be recorded was in a color photograph on the actual film was the negative of the value that we wanted. So if it looked really bright in the actual film, then when you printed it, it would be very dark, and vice versa. It's a cool color effect also, so people do this, like I think you can do this in programs like Photoshop and others. For us, making a negative is super easy. If it's a bright value, we want it to be a dark value, and vice versa, channel by channel. So a high value of 255 would go to 0. A value like 200 would go to maybe 50. I can't do the arithmetic in my head, but all we have to do really is subtract our current values from 255. Now, I am copying this over to my Python environment so that we can take a look at it in that context, and I'll kind of talk through it line by line, and then we'll take a look and see what it's doing. So here we're reading this is a mountain landscape picture, kind of been color modified, but we'll just go with it. And here I am making a gray version, and I'm going to display the gray version, and I'm also making a negative version. So CVT color was mentioned before. It allows us to do color conversions, and in this case we're doing the regular BGR to gray. And then I'm making another image, which is the result of taking 255 and subtracting the gray values from it. So this will give us that negative where bright things have turned dark and dark things have turned bright. And then we're going to take a look at that. So let's just look at those effects. I'm going to run the program, and then we'll come back and forth to look at the code. All right, I've run the picture, and we can see the results so far. So this up here in the left is the original color image. Down below is the grayscale version of it. So this is the result of doing that CVT color. And then what you see here is the negative of that. So if you notice, the water and this mountain on the left are the dark parts in the original grayscale image, and then they have turned very bright over here, and similarly throughout the whole image. Let's go back to the code for a second, and we'll look at what's going to come in next. All right, so the next thing I'm going to do is to do the exact same operation that I did before, but on the color image. So we'll take a look at what happens if you negate the blue channel and the red channel and the green channel. Those are all negated separately, but we get some interesting results. So We'll go back to my desktop and I'll just have it move on. So there, this is what we get as the overall negative. I'll take the negative gray down here. I'm going to get a lot of Windows copies of this picture. So if you think about something like the sky in the original was blue, if you think about the BGR values, that means the blue value was very large, green and red were relatively small. When we've done the negative, blue has now gone to be very small, and green and red have gotten larger. You can see it shades a little bit more towards, there was a little bit more green maybe in the original sky, because this is shading from orange to red, so the green value is also not particularly large at this point. But otherwise, every other color has done the same thing. It's flipped to the opposite side, and we get this really interesting negative effect. All right, let's go and see what else we're going to try. Because the next ones are actually getting at what we want to do, because the very next thing in the code is a use of this function I mentioned before called split. You say cv2.split and you pass it a color image like our original image, and it returns a tuple. I could just say one variable here and capture the channels that way. That channels would be a tuple with 3 different arrays in the tuple. Because multiple values being returned from a function is so common in Python, we actually are allowed to unpack tuples that are coming back from a function with this special kind of assignment statement. So instead of having a single variable on the left-hand side, we have 3 variables in parentheses and separated by commas. It has to match the size and the structure of the value being returned. So if it's a tuple with 3 values that comes back, we have to have exactly 3 variables here. So BC will be the first channel from the tuple, GC will be the second, RC will be the third. It lets us just kind of quickly unpack the 3 values that split is returning to us into 3 separate variables. What am I doing next? Well, I'm computing for each channel. I'm computing the negative of it. And then I have 2 examples where I've only replaced one channel with its negative. So here I'm using the merge function. Merge takes a tuple with 3 values, 3 channels in it, 3 arrays in it, and it puts them back together as a single image. So here I'm giving it the new modified negated blue channel and the original green channel and the original red channel. And down here I'm calling merge again. I'm giving it the original blue channel, but I'm changing the green. All right, so let's go back to look at our code, or to look at our run of the code. And I'll hit space, see what else comes up. All right, this is the one where the blue channel was negated, but nothing else. So you notice some of these, the blue values look considerably different. And here I'm going to do the green channel and nothing else. So we get some beautiful, interesting, and very bizarre color effects by messing around with the channels in this way. In the previous video we learned about like brightening a single channel or darkening it. Here we're learning that we can do things like negatives to a channel. We can also just take the channels apart and shuffle them around and then merge them back together again. And you're going to play around with that a little bit in our activity, and it was in the reading as well. But you can see like splitting apart and merging can let us do some really fun and interesting color effects. It also lets us focus on just one channel of an image if we want. So we can split it apart and do more processing on just the red channel and ignore the others, if that makes sense for our given task. Oh, yes, and I have one more here, which was basically the same thing again, where I used the negative of the red channel. You can see the original picture didn't have a lot of high red values, so when I did the negative, it got really, really red on the other side. And the points in here that look more green, those are the places that had a high red value before. Here, I'll move this into where we can see it. All right, so this program is available to you. If you are looking at my notes document, you can grab this and see what's happening. I just wanted to show you how easy it is to do negatives. All right, so we've finished discussing things you can do with split and merge, or just using an example to show you how you can pull the channels apart and put the different channels back together again. The next topic, the final topic, is to talk about regions of interest. So this is going to keep coming up. We want to do this all the time when we're working with images. We want to pull out a rectangular section of an image and be able to manipulate it, look at it on its own, or just report it back as something that's of interest. So what I did in this first sample program, which I'll scroll this up just a little bit. The sample program, I took that mushrooms picture that we looked at a little earlier, and I, by hand, figured out where two of the mushroom tops are. And I have done slicing to slice out those regions. So let's interpret this together. So the first region of interest, the first mushroom top, starts at column 135 and goes down to column 230, and then, row 135 down to row 230, and at column 50 going over to column 170, because it does rows first and then columns. The second one starts at row 120 and goes to 215, and it's further over to the right because it starts at 255 and goes to 390. So I believe I have this in my code, and we're going to switch over there and take a look at it and run it. All right, yes, so here's the program. I talked through these first couple of steps before we read in the mushroom. We're going to display the original. Then we have these two steps that are carving out regions of interest using slicing. And I actually also did this. So I took the same coordinates right here. They had to be moved around in order a little bit to be like the x1, y1, x2, y2, so that I could draw a rectangle where that region of interest actually is. And then we're going to show the marked image, and we'll also show the two regions of interest. They're going to be quite small, so we'll have to see what we can do to see them. All right, so what you can see here is the original mushroom picture. You can see the yellow rectangles I drew where the regions of interest are. And here are the regions of interest themselves, the region of interest 1 and the region of interest 2. Now, I want to point out something to you. I don't know if you can see it so well in the picture, but there's a little bit of yellow showing around these mushroom caps. And what I might do is to vary this program a little bit, but it actually brings up one of the main points about a region of interest. When you do slicing with Numpy arrays, it doesn't necessarily copy the data. It doesn't give you a copy of the data from the original picture. It gives you a view into that original picture. And that means that when you make changes to the region of interest or changes to the original, they show up in the other place. It's like aliasing with lists, but kind of on a grander scale. So here, because I drew yellow rectangles around these mushroom caps with the same coordinates, then the yellow actually shows up in the region of interest as well. So I'll show you that it doesn't always happen. I'm going to comment out the two rectangle calls, and I'll comment out the marked. All right, so here we have our original, and we have region of interest 2 and region of interest 1. And if you look closely at them, there's no yellow around the edge because they weren't marked then. But if I add those yellow rectangles and I view this region of interest again, I will see the yellow. It will show up. And if I make other changes to the region of interest, it will also show up in the original. So, all right, so I want to demonstrate also this connection between the original picture and the region of interest a little bit more. So what I'm going to do is to change one section of the image to make it different. So I'm going to say ROI, I got to click in the right place, ROI 1 from 0 to 20. And let's see, green is the dominant color in this picture, so I'm going to get rid of the green in this region. Maybe I should make it a little bigger. Let's make it 40 by 40. I think that will work. So I'm saying slice out this region of the region of interest from 0 to 40 in the rows and columns, and the one channel, which is the green channel, set all of those values to be 0. We've done things like this before to set colors, background colors, but now you're understanding hopefully a little better what was actually going on there. Let's try this. All right. Now, the original still looks like the original, but if you look at this ROI 1, notice there's now a very magenta-looking patch in the upper left corner of it. That's because we took all the green away there. So that's our 40 by 40 patch. Now, why isn't it showing up on the original when I said it's actually shared? That's because in the code, we only displayed the original before we actually made the regions of interest, and we haven't redisplayed it since. Changes to images don't automatically show up in the ImShow. You have to re-show the image to see the changes, if that makes some kind of sense. So what I'm going to do is I'm just going to take this ImShow from the top and we'll move it down here. So all of them are shown at the end, and we'll see what happens. There we go. Now, because I waited to show the image till after I'd made this change to the region of interest, you can see that the same little magenta patch shows up on the original. So these are a couple of things you can do with making regions of interest. It's really just slicing with Numpy arrays, but you do have to watch out that they are shared data. If you really don't want them to be shared, you can make a copy of the region of interest, and then you'll have a copy that looks different. But oftentimes we might actually want it to be the same, or it doesn't matter to us, and so we can leave it as is. All right, so we're again introducing more tools that let us manipulate images in different ways. The theme for today was kind of pulling images apart. So the first thing we looked at was split and merge, which pull apart the channels or put them back together again. And the second was this idea of a region of interest, which is basically just a rectangular chunk of a picture that we take out and can view independently, work with independently. We just have to remember that unless we copy it, it is actually just a view of the original data, and changes that we make to the region of interest will be reflected in the original, and vice versa. All right, these are some tools we can play around with to do fun and interesting things. We're going to stop right there, and then we'll pick up in another video by starting to look at how we can work with video itself. So instead of just looking at a still picture, can we connect to a webcam or read a video file and process the frames of that video as separate and independent images? And that's what we're going to be headed towards. I will see you all very soon.